As we go on to topic 3, and we've had our quiz, we want to just do a little review again. Again, I think repetition is the key to a lot of this. We have here 3 terms. And how do you define a term? Well, by definition, it's items that are separated by either a positive or a negative sign. So there's 3 terms here. Now, how do we find degree of a term? Well, degree of a term is the sum of the exponents on the variables. So there's a 1 there, there's a 1 there. So the degree of this term would be 4. The degree of this term, there's a 1 there and a 1 there, would be 2. The degree of this term would be a 1. And we can add, just make it another term. How about a term like this, in which there is no variable? Well, we say the degree of that is 0. So this is a 4-term, what we call polynomial. Now, there are other words to describe polynomials. If there's only 1 term in there, it's a monomial. If there are 2 terms, it's a binomial. 3 terms, it's a trinomial. But any of these are what we call a polynomial. And these are just smaller categories when they're listed this way. So for example 1, they want to find the degree of each term. Well, the degree of this term, we said then, would be 1. This would be 2. This would be 3. Now this one is 4, and this one is 1. So the degree of the term would be 4. And for something like this, where you have a polynomial that has 3 terms, you pick the term that has the largest degree. So the degree of this one would be just the 4. You don't add the different terms together. So up here in this polynomial, the degree of this would be just 4. Now the degree of this term is 4, and the degree of this polynomial is the highest degree, which is 4. And this is a monomial, binomial, and this is a trinomial. Now for example 2, they ask us to define a polynomial. Well, this is basically the form of a polynomial, where you have a function is equal to something, and this part is the rule that governs. All right, going on to topic 3 now. They want us to simplify each polynomial by combining like terms. So a quick review of like terms would be something that has the same variables. Now they could be in different order, but as long as they're to the same power, these would be like terms. Now, when we combine like terms, and this goes back to chapter 2 somewhat too, we only combine the numerical coefficient. The variable portion stays the same. So 2x's plus 3x's is 5x's. 10y's minus 8y's leave us with 2y's. Now, keep in mind, if there's no numerical coefficient in front, we can put a 1 there. There's always a 1 there. So we have 1xy minus 2xy's would leave us with a negative xy, and then plus 3x. We only combine those that have identical variable portions. Now, as we look at letter D, we might say, which are the like terms? Well, x to the first. So again, we have a negative 1x and a positive 2x will leave us with a 1 that we don't write, x. And then we have a negative 6x squared and a negative 3x squared. We just add the numerical coefficients, giving us a 9x squares. Remember, the variables don't change when we're just adding or subtracting them. As we look at this, we have a negative 9y and a positive 8y, leaves us with a negative 1y, and we don't write the 1 usually. Plus 2y to the 5th. Now for letter F, we have to identify our like terms. Well, this is 1 and this is 1. So we have a negative 2 and a positive 8 leaves us with a 6xy squared. And then this is 1 and this is 1. So there's a negative 1, positive 3 will leave us with a plus 2x. And then there's nothing else for this, so this just gets 3/5. And generally you put the higher powers and have some kind of order to it. Now, when we are adding polynomials, and I took a little time to set this up, here we see something in parentheses and something in parentheses, and there's a plus sign between them that indicates addition. So I strongly suggest that you line them up in vertical like-term columns. So now you just add up these columns. This will be a negative 3y squared. Now notice we have a negative 2y and a positive 2y. This is going to be a 0 that we don't write. Just to show you, that becomes a 0. And this will be plus 12. So again, we don't write the 0, and this is our answer. You could put them closer together, of course. Now, for something like this, again, it's something in parentheses. This is in parentheses. There's a plus between them. Just line them up in like-term columns. So now you have a negative 6 and a positive 2. This is going to give you a negative 4x squared. And this is going to be a negative 10x. Now you could do it horizontally and mentally. But again, I see many students who, they just kind of lose track of signs and things. You want a way so you get the right answers. These shouldn't be difficult. Now, for letter C, they have it set up vertically already. So it's just a matter of adding them up, and we could take away the parentheses here. So this will be 12x squared. This is going to be a negative 2x, and this is going to be a negative 5. And, go back and check your work. Is it really what you wanted to put there? Now, when we are subtracting, this is where it gets a little more challenging. So we see these terms are negative, that's okay. But now they have this negative sign here, and then this in a parenthesis. So what do we do to subtract this? This is saying subtract these. And the answer is we take away the parenthesis and change each sign. So where this was positive, this now will become a negative. And where this was positive, this will then become a negative. And now we add them up. So this is a negative 6x squared. Now we have a negative 3x and a negative 7x will give us a negative 10x. And this is a positive 9 and a negative 10 leaves us with a negative 1. Now the same thing here. You are asked to subtract this. So we're going to take away the parentheses and change all of the signs. So this will become a negative 5. This will become a positive 3. And this will become a positive 22. Again, we subtract by changing the signs and now adding. So for this first column, we have a negative 5 and a 4, which leaves us with a negative 1 that we don't write, x squared. Now, this is a negative 3x and a positive 3x. These just cancel out. We don't write the 0. And here we have a negative 15 and a positive 22 will leave us with a plus 7. And then now this one we have to set up. So we can write it 2x minus 2. Now we are told to subtract these. We do so by changing both signs. And then you can put them in like-term columns. So this was a negative x. It now becomes a positive x. This was a negative 2. It now becomes a positive 2. And we put our line. And keep in mind there is a 1 there that we don't usually write, but you can. And now this will become 3x. And these cancel out, and that's our answer. All right, we'll go on to 5.4, which is today's lesson. Now we're asked to match these functions to these graphs. So looking at them, one of them is linear. Which one is linear? Well, graph number 2. And this is this line that's in slope-intercept, y equals mx plus b. So which equation is like that? Well, right here. So our y-intercept is 2, and our slope is 1 over 1, so over 1 up 1. So this would be C. Now we may have mentioned that when we see a graph like this, this is a parabola, which is x to the second power, and we see it's going to go through the y-intercept at 2. So, well, I should say a negative 2, yes. Negative 2 here. So this one is B. Now the third power, x to the third power, has this kind of shape, and it's going through the y-intercept at -1 right there. So this one is A. All right, we'll wind this one up.